All right, hello everyone. Welcome back again to ECS 179 Gameplay Programming. Today we will be talking about the factory pattern. Today we'll be playing more UN Squadron, and your TA, Kyle Mitchell, will be helping us with decomposing the game objects, the game systems, into things you could implement in Unity. So we'll be doing a bit of whiteboard component. I'll probably pop out another camera so we can see, or move this so you can see the whiteboard while we see gameplay, so we can have these side by side. All right. 1 second. So you may have to, it looks like I had a hard time, the push didn't go through for this project earlier, but we are looking at the factory project inside of the gameplay programming projects folder in the gameplay programming repository for the class. So we're going to be going through a live example of the factory pattern today. Now I will update this and send it out. I will also update a spreadsheet and send it out as well. A week from now, so next Thursday, we'll be playing some of your code. So this is a participation point exercise. So what we are going to do is have you implement your own factories in this system in small teams, and you get to pick your team size and give a team name and everything. We'll have you demonstrate your code on screen. I want you to implement a new bit of functionality that we can import as a Unity package into my project and run your own spell factories. So we're delving into Magitech today, people. Buckle in. All right. So more details will come on that. I'll send a Canvas announcement with all the details, sign up forms, etc. Okay, so here we have our Unity project, and I'm going to hit the front lights here real quick so you can see a little better. There we are. So it's a fairly simple project. If you open sample scene, that is the scene we'll be using. Main camera, a spell factory prefab, or an instance of a spell factory prefab with a body and 2 stacks. It's a factory. Right. Directional light and the ground. Fairly simple scene. We have our assets folder where we have some resources. These are resources used for the current spells that our spell factory can fabricate and cast for us, including a black hole, a fireball, and meteors. Our scene with our sample scene, and our sets of scripts to make all this run. All right, so let's just take a look at what this looks like. All right, so here's our factory. I opened up the statistics window just so you can see things. You can toggle the stats on and off. And it's actually picking up some of the the fireballs. So this factory, it's going to be constructing instances of objects for us based off patterns or templates, which is the basics of what factory do. They take a design sketch and they make something, and they make it en masse, many of them. Right? So this is what our factory can do. It can make mini fireballs. It can make meteors. And black holes. Obviously physically accurate black holes. You should press it, segfault. That would be the black hole, right? Memory destroyed forever. Quantum decay. So let's take a look at how we do this. It's also a handy pattern if you have like a spellcasting character in an action RPG or something of the sort. Okay, so we have a set of scripts. The first one here we should look at is the iFactory spell. So this interface is sort of at the heart of the factory pattern. This is the mechanism of decoupling. Like we keep talking about, we use interfaces, inheritance, etc. to give us points of decoupling in code or subscribing to a publisher subscriber model, right? All of these serve similar functions in that they take hard links in code and they make those soft links. They cut the conceptual dependencies from one bit of code to another bit of code. And the factory pattern does this as well. So basically this is the contract. This is the decoupling thing. This is the one constituent bit that has to go from the factory to the thing the factory produces, the thing that makes it a sketch. And this is the make command. So we're being very simple here. We're saying, hey, I'm an iFactory spell. Factory, to make an instance of me, you must call make. So this factory can make various things based off the different design sketches. So often with the factory pattern, you'll be able to make various things with various properties. They can vary a bit. Like if you think about a car, like if you go to like the factory that makes like F-150s or whatever, or Teslas, there's a whole like set of specifications you can have, packages that you can enable, customizations that you can do, but there's still like the core of the factory working. Those cars are still 90% the same, but they can be tweaked on the margins. That's what factories are good at. So here, our factory is making spells. And our variation here are 3 types of spells that it can make. So fireball, meteor, black hole. All of those implement the iFactory spell interface, meaning that they can be made by the factory. They are a spec that is something the factory can handle. So basically, make returns a game object. Taking a look at the fireball maker. It's a mono behavior, and it's an iFactory spell. And basically, what it does, the make function, takes a game object, or instantiates a prefab, and places it at local origin, and returns it. Right? Scripts, we can make a bunch of specifications that make something much harder to create than this. Here, a lot of the specification is actually the prefab game object that we're creating from. So that's where a lot of the details are handled. Taking a look at this, we have our resources, and here's our fireball prefab. Its heart is a particle system. And we have the particle system component in here, which is making a bunch of small particles with these specifications. You can play with it. We can make the particle lifetimes and speeds much bigger, right? You can have it rotate and spin. You can give it various physical properties. This is one of those built-in handy Unity components for handling many particle effects, and each one of the particle effects can in themselves be a game object. So this is a really flexible system. All right, so it's fairly simple, right? A fireball is a game object without a mesh, right? So there's no mesh renderer here. All the visuals and all the rendered components actually come from the particle system itself. So we have a transform, we have a fireball motion script so it moves, and we have a particle system that references a material. Completing this loop, let's go look at fireball motion. This is a simple script which has a speed that you can set. You can set our fireball speed. And we basically have an update where we get the current position of the object, and we take the speed times dot delta time times the forward vector of the object, and we transform the position to be that. So we're doing to have that increased position in forward direction. Now, we could use the physics system for this. That's totally fine. This was just one quick example of how to make something move on the screen. A lot of folks, when we get to this point in time, have dealt with the Unity physics system. We did an example 1. We started dealing with handling our own movement with our own speed and scripts with our own vector math instead of relying on the physics system to move everything, because at this point you may want to think about how do you stylize motion in your game. So we are sort of moving away from physics system and rigid bodies and moving towards handling it ourselves, mostly as a pedagogical move. I imagine most of the games that you will make in Unity will rely on the physics engine, but a lot of them don't. Like 4X games don't tend to, platformers like Mario don't tend to, because you break physics a lot. And so if you're constantly fighting the physics model with your own stylized motion, it can be very difficult. All right. So this should be code that you've seen a lot before. This is like a canonical way to move a thing. Simple example. So that's our little fireball prefab. So once again, shooting a prefab. Now we've seen the fireball. You can see what it looks like. And there's similar motion. There's similar things for the meteor and the black hole. All right, so now let's take a look at the factory. So we've seen like how to implement a very simple thing that is constructed, a thing that is made from a pattern by a factory. Let's take a look at the factory itself. So here is an example of a factory sketch. So I want to give this as a sketch to you to use in the future if you want. Typically, factories are well constructed when they have a well-defined and usable list of things they can make for you to choose from and perhaps parameterize. So here we actually have an enum with our spells in it, fireball, black hole, and meteor, that we can then use and adapt later. We also have a private static int with a serial ID. How many have used this unique identifier in class patterns in a static way before? Yeah, how did you use it?
For my own entity system, I had to ID them based on content.
Exactly. This is a common pattern for you to keep a unique identifier for every new instance of an object that you create. And it's static, so it belongs to the class level. It's written on the blueprint. And often they're paired with a static constructor. How many of you have used a static constructor before? How many of you knew there was a static constructor? Yeah, okay, so this is interesting. I thought there'd be more hands. Fascinating. Okay, so a static constructor is executed when the class definition is loaded, not when an instance is created, right? So it's one of the earlier things that run. In this case, we could initialize our serial ID system. For games, it's very handy, particularly when you're doing things like object pooling. If you begin your object pool or your reference to all of the things of that class, all the instances of that class at the static level, and you simply call a function like add to object pool in the constructor, the instance constructor, instead of the static constructor, you're kind of off to the races. This is a very nice pattern to handle collections of like things in the class. Yes. I'm sorry, what was the last thing you said? It's a little hard to, I have the ears on a lot today.
Is it normally used for the single design pattern?
For the singleton design pattern? Yes, static constructors and particularly a static instance of the variable is at the heart of the singleton design pattern. So how many of you have heard of the singleton design pattern before? Okay, it's definitely one of the more common ones, so we have maybe 10% of the class who has heard of it. A singleton design pattern is useful when you want to enforce that there is only one instance, one canonical instance of an object. These are often useful for things like your graphics system or your physics system. For me, it's often been my social AI systems that drive my characters. We want one canonical like social state, character state, story state that everything can refer to and one central point of reasoning. How you pull this off is you have a static instance of the class. So something that lives at the blueprint level. And you don't actually, you invalidate the constructor. You put a printout in the constructor, or you throw an exception in the constructor, or otherwise a strongly worded debug symbol and exit execution when new is called. because that's not what you want. Okay, let me walk that back just a little bit. That's pretty extreme. Typically what happens is when you call new, it will check to see if that static instance already exists. And if it doesn't exist, it creates the static instance for you. And if it doesn't exist, it will return. So typically you don't want to call new with singletons. It's bad form. You want to do it exactly once in the static constructor, or the first time you want a reference to it. Well, how do you get a reference to the object? Usually a static method called getInstance. This is one of the interesting cases where a private constructor would be very handy. It's a little idiosyncratic to have a private constructor, but in singleton it kind of makes sense because you only want to get access to that instance of an object through a static method called getInstance. And so every time you want to use it, you get the one canonical static instance of it and you get a reference to that, and you're off to the races. I can send out some readings on the singleton pattern if you'd like. It's a good one to get started. It can also be a bit of an anti-pattern. Unless you know exactly what you're doing with it, it can be very destructive because it can create a bunch of hard links in your code, the exact type of behavior we want to avoid with software engineering. It makes hard links to a particular static instance, to a particular bit of code, a particular getInstance function call, instead of decoupling through at a layer of abstraction. All right, so maybe that was a little bit more about the singleton than you may have wanted to know today, but there was a brief, a design sketch of it. I don't have any sample code to show you right now for it, but that could easily be provided. We could even create one if we have time later in the class. Happy to sketch one out for you. All right, so that aside, we now have a private static int back to our factory, and we simply have a function that says, hey, get new instance. So this is where we can say, hey, factory, give me a new spell of one of these three types. And the factory will take care of creating it, calling the right blueprint, getting the object, and passing it back to you. So get instance of a spell, and we use one of the types of spells. So let's look at the instantiation of this, an actual version of this called spell factory. So we've seen that small sketch, that high-level sketch. Here is it filled out. So this is our Arcanum namespace. I forgot to say that earlier. It's our Arcanum spell factory. We have continued on with our public enum of spells. So Arcanum dot fireball, or Arcanum.spells.fireball would be reference to the fireball part of the enum, black hole, meteor, etc. I'm a big fan of enums, and they're used for regularizing your code. I encourage you to use plenty of enums. Here we have our required components. So we want to make sure that before we run our factory, that all the components necessary that exist on the game object. So we want to make sure that we have a black hole maker, a fireball maker, and a meteor maker available. And we have our spell factory class. So now we're actually into creating our class. The major portion of it is build spell. And it takes a spell type, one of these. And we triage it to with an if statement, or you can use a switch statement, case statement. I tend to use ifs because they're a little less human error prone than cases. And they usually compile down to about the same thing. There's not a big efficiency gap between the two. So what we have here are getting black hole maker game object components. So basically we're calling the make function for each one of our object makers. So this is actually accessing that blueprint that then calls make, that then constructs an instance of the particular prefab that we care about, reifies it, instantiates it, sends it back to the maker, and then the maker sends it back to the factory, and the factory takes it from there. Same thing with fireball and meteor. Now you can actually see a case here. Does anyone see a way we could actually maybe turn this and maybe have the lines of code here? That we could take it from this case statement and make it more compact and less error prone. This is some pretty advanced programming moves. I'm going to let people digest a bit, and then I'll call on you. Here we're getting into a stronger, more I guess, past junior level of programming when you get to this sort of thing. Okay, you've got an idea too? Hang on. Well, I'm just letting people think. And I'll call on you both in order and not say a word until you both say your words. Didn't realize you were doing a leak code interview today, huh? If you were stuck in a blender, shrunk down to the size of a matchbox and stuck into a blender, how would you get out? Anybody still thinking? What do you got any ideas? Okay, let's continue on. 1, then 2.
Well, I guess I don't really have a specific answer. I just noticed that like the whole become like you're getting a component of something, and then that something you change kind of become the position of. So, and since that something is based off of a very like specific like component type that you find based off of additional, maybe those could be shortened into something where you really just. I don't know how exactly to do it, but like just pass in like the type you're trying to get, and then like have those just 2 lines of code run.
Ooh, you're getting pretty. That's interesting. You want to add?
Yeah, I was thinking something really similar, and again, I'm not sure how you do it, but I was thinking because maybe if you had presented something of a dictionary where the type was the key and it led to something like black hole maker or firehole maker.
Ooh, between both of you, we're getting really close to a cool solution. Yeah. Yeah, that's interesting. Would that invalidate the factory? So basically, you're doing a factory level, like you're using a blueprint directly, and the factory is basically a simple triage. So it'd be kind of like the specifics of that solution. You kind of like want some like catalog to send out to people so they know the options of the factory, right? So there's like this proxy that enum stands for, which is, hey, for outside world, this is what the factory can do. If you already assume someone knows which blueprint they're passing in, we need some sort of additional thing. But that would be a cool enhancement for sure. Yeah? Something like that? Yeah. Yeah, so all of the...
If you make them all inherit from the same class, then rather than passing in the type of the spell, you could just pass in the script directly.
Oh, you mean like an I spell?
Yeah.
You mean a classic interface decoupling mechanism? Exactly. Yeah, so that's one way you can do. So what you want is the thing that all of these have in common. Instead of having it be like a compile time enum or list, you have something that your factory can keep and update dynamically at runtime that still serves this enum-like purpose, but can then go in and simply say, I want to build a type of spell. If you do have an external enum, like if you want to factor in a solution like yours, you could have still an external list of enums, maybe perhaps a dynamic enum variant where you could go in to get a list of options, pick from those options. Those options could change dynamically at runtime, unlike the standard enum. And then that specifier would be passed in, triage through all of these like registered makers that exist at the class level. And then you could use a dictionary to do the same parsing that these if statements do. That's definitely one solution. Another could be to use reflection. And here you have each one of these enums even like directly mapped to a class specifier like arcanum dot fireball maker, right? And so this could be bound directly. And so you could just simply say, hey, make a fireball dot get my value and pass that right here directly into the get component call. So you'd use the class system and the C#'s ability to examine classes to see if it had actually implemented correctly the I spell or the spell factory interface. make sure it had a make function that returned a game object. You could do all this inspection at runtime or at the time that you enter these new makers into a dynamic enum or catalog. Right, so there's lots of ways you can make this pattern more fancy and more usable. This is a serviceable baseline pattern for a small factory where you do have to deal with a bit of repeated code, right? But we all keyed on this thing where repeated code looks a little funny, right? A lot of these lines are pretty much the same. The difference is here and here. That seems like something you could template out and make abstract and collapse all those lines into one version with maybe a little bit of processing at the beginning and processing at the end. Yeah.
I sort of have like kind of a bug thing. You named fireball. You named the variable fireball in the meteor at the bottom.
Yeah, I'm just deleting my code so it runs. Yes?
Like at the very bottom, it says var fireball in the meteor.
I'm sorry, where 28, let's see what you're saying. This component, meteor maker, meteor type.
It's just like, it's named fireball.
Oh, yeah, you're right. It doesn't actually matter. That was a copy and paste error. Thank you for catching that. I wonder how long that bug's been there and no one said anything. And I just didn't see it because I wrote it. It's like editing your own papers. You know, sometimes you get too close to your own code. Thank you. That'll update. Excellent. No code is perfect, especially mine. Right. And so the factory is completed. This factory is self-actualizing. We hook it into the update cycle. Just to make it a succinct example, usually you'll probably have some other brokering larger input game object living in script home or being attached to your player or whatever the factory entity is. That would be responding to input and extraneous game world actions, exogenous game world actions, and invoking build spell. All right. One more time. I wonder if I broke anything. Yes, I know. I didn't use a serial ID factory. I've also didn't actually use the factory at all. That's a sketch. All right. Just to complete, yes.
So in the like general factory one that you gave, like what exactly would you use the ID for? Because like we didn't use it here.
Each one of the spells that you would generate
You
would get an ID. So everything the factory makes would get a serial number. For returns. My fireball wasn't destructive enough. All right, just to complete the loop, Meteor Maker is quite simple, returns an instance. Meteor Motion, also quite simple. We're moving. We added a gravity-like speed movement. We also gave it a movement vector, and we set that vector to be diagonal down. And Black Hole Maker. This one actually just relies on gravity, which I think is pretty hilarious. That was a bit of snark on the instances of black holes and large gravitational objects in games, which are never physically realistic. And one last interesting thing, the prefabs of all these, the black hole is the interesting one because it has a shader. Here is the shader effect. We're using what's called a Fresnel shader, which has this sort of pattern to it where it's darker in the middle and more opaque in the middle and more transparent on the outside, so where there's a color difference in gradient from middle to outside. These are often used in shield effects in games. We will see an effect of that in exercise 4. We're doing 1 minus on it, so we're inverting that effect. So the outside is light, the inside is dark, and then we're applying that to the alpha value. We're giving the base color as a color 3 black. So we are changing the alpha to be more transparent as we go to the edge. And this would actually work when looking at it from any direction, because it's a three-dimensional fragment shader. Taking a look at that again. Discard. Scaling a bit so we can see it. Guess the scale doesn't really handle well, but you can see that transparent effect. Okay. Questions about the factory pattern? I think it's a pretty straightforward pattern. I think you all can handle it with much aplomb, without much circumstance, but it is now a tool in your tool belt, and you should practice using it. And to incentivize you practicing it, well, it's going to be the heart of exercise 4, but I want you to create your own spell factory packages. I'll be sending out documentation, like a Google Doc style little tutorial, and a sign-up sheet. So the tutorial will tell you, walk through how to make your own factory. We'll give you a Google Drive folder to dump your own package into that I will then load before class on next Thursday. I will give you a sign-up sheet so you can make a little team name for fun, get like 2 or 3 of your fellow class peoples and get together and each one make a spell for your spell factory. So that's sort of the rule. Each person should make their own spell, so we know how you've interacted with your factory. Basically, I want your spell factory to be called Spell Factory to regularize its use as a package. I will be importing, when I use it, the only thing I'll be looking at is dragging an instance of your spell factory in your package onto the scene, and it should work, just work. So we want to have a good encapsulation in your package. Package. You'll also get to see the examples from the previous classes that have done this, so you can get an idea of what they've done, and each year they get a little more just broken. So have fun with it. I'll be running them on my machine up here so it's recorded so everyone can see, but I'll let you talk about it and perhaps even run it if you want to throw in some surprises. Run the mouse. And if you complete this, each person in your factory team will get a participation code. You do this, that's 1% of your grade. Done like that. What efficiency. Okay. And I will update this. For some reason, my push failed. I probably just had bad EduRoam in my last meeting. So if you look on the projects, the Spell Factory project right now in the GitHub repository for the class, you'll see that it is last year's project version. So I'll update it right after class to be this year's project version. All right. Gameplay time. One moment while I set up. Feel free to ask questions while I do this, though. Routine with UN Squadron today. Let me make sure it's all set up and ready. All right, looks like we're good to go. Okay, we have that in the bottom right. Let me actually change some things around real quick. Goodbye, have fun whoever left. Hope you have a great day. We'll put in RetroArch here and we'll show it. And we'll put the webcam here. Let's take UN Squadron and make it a little smaller, put it up here. We'll make this a little bigger and put it down here. Actually, let's do it both side by side so you can see the gameplay and you can see the screen. So what we're going to do is point this at the whiteboard because Kyle is going to be helping us out today and running through this exercise. Yeah, fine, this will work. So I guess you can see what they're seeing on the board. If you want to make borders, hello, feel free.
Yeah.
Okay, so the goal today is for us to spec out how we would make various solutions in Unity, in a game engine, to implement the various game mechanics we're seeing on screen. We started this, the basics of this, last class. And let me turn the volume down just a little bit. Yeah, it's cranked up pretty good. So I'll be joining in the fun. Kyle will be helping us out, and we will get this going. All right, so I will step out of the screen. We have you there. So first off, the title screen. What would you do for the title screen? Oh, get back to the title screen. What are the basic parts here? Yeah. Two buttons, right? Okay, so we have game start and option mode.
Yeah, so like you have like an interface, like have your game title, and like I think that they describe like what this game is should be like or like talks about with like little some kind of information that suggests like what this game looks like.
Yeah. So in this case, we have a timeout here, which will go into a bit of story building, right? An intro scene, a contextualization, an opening eyeball with a shining light in it to show how powerful and sentient this person is or whatever. But let's be a little more specific. So those are some general things, like what are actually elements? What are assets we'd have to put in the screen? Yeah.
I feel like we would need like a title screen controller. This is like very like you go up and down, you can select one of those things, and I think that's a very distinct set of controls from, for example, the actual gameplay.
Yeah, this is an arcade game, right? It follows the arcade game conventions, right? So the type of instructions you need to give someone must follow the conventions of the platform you put it out for, right? In this case, there was already probably a controller with a bunch of instructions written in like plexiglass or acetate cabinet right in front of you, right?
But like, that controller would need to have like a software implementation that interfaces with the rest of the code. So
Yeah. So you would need the equivalent of get button, get up, get down. You'd have to get the D-pad motion or get the joystick motion. Thumbstick controller. We have text. Looks like pretty normal rendered text at the bottom in the classic in a classic font, classic Capcom font. We also have whoops.
Well, you just did something interesting there.
Yeah, I pressed start.
Yeah, you press start.
I pressed start and it went. But there was also assets for the title, right? Here we have a pretty standard select screen where we have text, we have various assets, we have some highlighted, some alpha and out to show which one we're selecting. It timed out on me, so we just selected this one. We'll save this back for later. Let's get right into gameplay, where it's a little more interesting, I think. I don't have my money. Bombs it is. $2,000 for bombs. That's a deal. All right. Pausing it. What do we got here? What are the elements you see that could be represented as unique things?
Stats, so you have something keeping track of everything that you're hitting and counts and everything up.
Yep. Stats, cash, score. We'll see how score interoperates later. Yeah, 1 and 2.
Player in the background.
Yep, player in the background, player object, and parallax scrolling in the background.
Yeah, map. Like the background for like see a desert here.
Mm-hmm. Yeah, the assets that make that are used in that parallax scrolling algorithm for sure. Anyone from this side of the room? I'm not asking for a lot of magic here. We're just, what are the things you see on the screen? Yeah. Health bar. Health bar. So we're looking for the static things right now. So we have like this text, the score, this picture, POW, total, health bar, bombs. What's generally that class of things in a game? UI. What type of UI? There's a particular term for it. A HUD. Heads-up display, which is particularly apt given that you are a pilot in a plane. but somehow you have this like drone following you from the side, and that's how you control your plane. It's a weird metaphor, right? Although I'm not sure drones really existed in the way that they could do this in the 90s, so. A hang glider.
That's right.
Due to the hang glider and the camera.
Yes.
Not a GoPro, because those didn't exist. But yeah. VHS recorder.
Yeah.
What other systems do you see here that we haven't mentioned? We've talked about the fact that bars exist. We've talked about scores and other things we keep. What are the other things? Yeah. Yeah, we have that item that we selected and bought in that first screen. We have the icon for it. We have its name, bomb, and then there's a 50 by it. No?
The helmets in the bottom left represent lives.
They are. It is a classic arcade game, including lives. Those of you who've played the second Legend of Zelda game, Adventure of Link, know how frustrating this is to have lives in a game that's meant to be played in your living room. Infamously hard game. What else? A couple things we haven't mentioned yet. Yeah.
You have the character portrait.
Character portrait. Yeah, the character portraits are fun. Give a little bit of the feel of what's in the cockpit. And you know, they had this was from a manga, right? So they had a bunch of cool art already to deal with and to play on.
Does the I forget in Squadron, does the face change like the main character in Doom?
Yeah, the face will
Yeah,
change.
okay.
Yeah, yeah.
Based on
They'll
how hurt you are.
grimace when you
Yeah.
get hit, and they'll they blink. They're basically alive. Yeah.
Of course.
Yeah. What else? What else we got? We're not quite done yet. We're close though.
I'm not sure if the bottom right is like ammo or something like that for the bomb, like it indicates where the bomb.
It is. It's how many times you can cast bomb. We haven't played live yet. Maybe you got that from last time, but yeah, that is what's happening there. So your ship can be a bomb factory. What else? What about the top? We have level 1, $100, POW total with boxes and numbers in them. What do you think's going on here? We have score and money. This is a very particular time in games. And both were useful. This isn't redundant. These are both serve purposes. It was an arcade game, so score is how you get on the high score list. The money is different. How do we use the money? What was the money for? Yeah.
Money is used to buy weapons.
Right. It's real. It's literally money. It's a currency system used in the game. What about POW and total? We probably haven't seen those yet. That's actually a light RPG element. Once you kill things and pick up power-ups, you actually become a better pilot. And the pilot we picked, Shin, he has lower thresholds, lower XP bars, lower XP thresholds to go to the next level. So he levels up faster. He also takes damage worse. He's worse at taking damage, but fast at leveling up.
Is the power persisting like if you die, you can still keep it?
Yeah, and it sustains through level to level. So you saw we had that overworld screen where there are different missions you could select. You keep your money and the planes you unlock that you buy from level to level. The things that you would lose would be the actual like bombs that you buy, the special power up for the stage. Yeah.
Does that mean that the government does not have a subsidized future for you?
Yeah, what is the rhetoric behind this, right? Are these like renegade mercenaries working with the UN? I actually haven't read the manga, so maybe they explain this. Maybe this is actually like diegetic, like this is part of the manga, this is like something they brought from the fictional world. I don't know. But you are paying this dude in a shop, like this worker at UN, this mechanic, to like buy you a new plane, and then you're paying him to put bombs in your plane. It's a little weird. And you're doing like these hit missions where you blow up convoys to get more money to buy better planes to progress through the game, right?
get a higher score.
To get a higher score.
So you 3 initials go on the
Exactly.
arcade cabinet.
Yeah, yeah. Okay, let's play some now.
Sounds good.
Level 1. There we go. All right, our power went down by 1. We're shooting some tanks, shooting some airplanes. Okay, which one's the bomb? There we go. Bomb, bomb, bomb. Everything we kill gives us a little bit of money, get a little bit of score. We hit our power total, so now our gun is better. We now shoot 3 bullets instead of 1. Bullets don't cost us money though. That thing had some serious firepower behind it. But what's different from the red ones? We hit the sprite limit. So we slowed down. Oh, I accidentally shot a special place in the sky. There are little hidden places that you can shoot invisible objects that will drop things for you. In that case, it was the icon for starting the screen, the little unicorn thing. This has to be Soviet, right? Oh, okay, I died. But now I'm a little faster, a little stronger.
Didn't realize we were playing Armored Core.
Yeah, right? I guess you can buy multiple power-ups. Okay. Now I have a mega crush. I'm playing a dating sim now.
What?
I'm gonna date some tanks. They're gonna be anime girls. Alright, so what else have we seen on here? We saw some gameplay. I leveled up again. My gun is stronger. You want to lead some discussion on some of these gameplay systems that we're seeing while we play?
So we have a level, right? We have this level that we selected way back when we started the game, right? What are the elements of this level? Yeah, it's an auto-scrolling level, right? Let's talk about the level itself.
Is the volume too high? Should I turn down?
Yeah, just
Yeah, okay.
so we have an auto-scrolling level. What are the other elements of this level in terms of things that we can see on the screen, minus, let's say, the UI? Right? We're not primarily interested with UI. Excellent. Yeah, we got enemies. Right? Enemies with various functionality. What else? Yeah.
You have primary fire and you have secondary.
Okay. Yeah. So we have a player that has multiple abilities, right? Okay. What else? We have projectiles flying across the screen, right? For both enemy and player. What else? Yeah, power-ups. Excellent. All right. Anything else? Yeah. Hidden items. Yeah. You leave anything out? Yeah. Background parallax, right? Go.
I don't speedrun this game.
Yeah. entirely separate subsystem. Okay. Yeah.
Iframes.
Yeah. That's interesting.
I need every one of them.
I'm gonna put that under animations. You think that's fair? Yeah. Iframes. Yeah.
At the end of the very like the first level, there was a boss that stopped.
Ah, interesting. Yeah. There is some sort of boss at the end. Yeah.
It seems like there was besides
Okay, yeah, cool. That is, I think, let's put that projectiles and their behavior.
Right on the chin. Reep, reep, reep.
Okay, we have a pretty good list. How about we talk about how we can actually create these things then? How we might actually do it in Unity in terms of game objects, in terms of functions, in terms of things that we would need. Where shall we start? Shall we start with... How about we start with some logical groupings? How about enemies? So we have a bunch of enemies. And we have various different kinds of enemies. They have different looks. They have different behaviors. They have different projectiles. What kinds of patterns would you use in your code? Maybe some patterns that we've already discussed as to how to create these various kinds of enemies in a very efficient way. Yeah. Absolutely. We could definitely use a factory pattern to accomplish enemy spawning. And we could even go further. We could say that every enemy has their own ammunition factory and projectile factory, right? So feints within feints within feints, right? Yeah, go ahead. Yeah. That's right. Yeah, definitely. There is, yeah, the AI for enemies. And are there any projectiles in this game that are smart?
I believe so.
Yeah, they're
there were
homing.
homing missiles by the enemies.
Yeah, they're homing missiles as well, so you could give homing missiles some sort of AI. Indeed. Anything else to add about players and enemy creation? And we obviously need those assets, right? We need what those enemies look like. However, what they look like can be a parameter inside of your factory, right? As well as your projectiles. Yeah. How about I think we've beaten auto-scrolling to death. You guys have already accomplished that pretty well. How about we talk about some of the stuff on the UI? So this is a very, very UI-heavy game. It's a 2D, right? It's a 2D game. There's a lot of UI, and it occupies a lot of the screen. How many of you have worked extensively already with Unity's UI stuff? Part of the Canvas stuff? No. Sorry, Canvas as it pertains to Unity, not UC Davis Canvas.
Oh gosh.
Okay. All right. So within the UI system, within Unity, every UI element that you create goes on something called a canvas. And this is basically a projection window on which all of your UI elements overlay your game world. So it's very, very common when you're designing, say, a 3D game. You have your level, and then you have your canvas object. And your canvas object may be massive in comparison to the size of the level. That's because it exists separately. It is just a projection window. It is very, very important, I will tell you this, as someone who has designed a lot of UI for many different projects. It's very important when you are designing your UI that you are smart about it from the get-go. Otherwise, you will be regretting it later. Something that we care very much about in the modern age is the scalability of UI. Whatever resolution you're using on your device, whether it's your phone, your computer, whatever, you want your UI elements to look the same. You don't want them to, say, end up on the bottom left when it should be in the top right. So always have some sort of plan when you're doing your canvas elements. Now there is a simple way to do this. Your canvas can be set to a certain mode. So the canvas itself has properties, including scaling properties. And every UI element itself has not a transform per se, but it has a rect transform. And that rect transform is basically this element lives inside of a rectangle. That is where it is supposed to go. And its transform, rect transform, are the coordinates within the canvas. So there's a very, very simple way to modify its position as well. Every rect transform has a certain, you can set its pivot and its position, and you can anchor it. And I might do a little tutorial on that in the future. I think that's very, very useful stuff to see. All right. What time's it? 3 o'clock.
Yeah, game over.
Sorry, got very, very passionate about UI elements because it is, in my opinion, one of the hardest things to do as a programmer is UI programming. So I'll leave you with that.